So today I'm going to show you how to calculate the 4 compactness ratios that are discussed in the lesson in Geometer Sketchpad. The first thing you need to do is to get an image of a district into Sketchpad. There are several different places listed in the lesson plan on the web that you can get images from, and then once you have one you can just copy and paste it into Sketchpad like you would any other image. Now that I have it in here, I need to measure the area of the district, and I'm going to do that using my polygon tool. And I'm just going to overlay an irregular polygon on top of the district. When you get back around to the beginning, just click on your first point again and Sketchpad will complete the polygon. Now that you have the polygon drawn and its interior is selected, using the measure menu, you can just measure the area of the polygon. Using the label tool and double clicking on that, you can label it area of district. Now that I have the polygon drawn, for convenience's sake, I'm going to hide the points that I used to draw it. I'm going to select the point tool and then edit, select all points, display, hide points. So I'm left with just the map of the district, the interior, and the area. Next, we're going to calculate the convex hull compactness ratio. And the first thing we need to do is, using again our polygon tool, we want to draw a convex polygon that wraps around our district. And I like to think of it as if I was wrapping a string around this district. Where would the string kind of catch? What parts of the district would make the string poke out? There's my convex polygon. Using the measure and then area feature again, we can measure the area of that district. And then the convex hull method tells us to divide the area of the district by the area of the convex polygon. So just doing number, calculate, area of the district divided by the area of the polygon. And my compactness ratio for this district, according to the convex hull method, is 0.72. Next, we're going to calculate the rock compactness ratio. For this, I've added a blank page to my sketch, which you can do using File and then Document options. You can add blank pages here, reorder pages, that kind of thing. And I want to copy over the map of my district, the polygon that overlays my district, and my calculation for the area of the district. So I highlight those. I'm going to copy them and paste them. I'm going to delete this other polygon from my convex hull method because I don't need it anymore. And what the rock method tells us to do is to construct a circle that's as small as possible but still encompasses the district. So using my circle tool, I'm going to draw a circle that goes on top of my district, and then I'm going to go ahead and measure the area of that circle. Now I'm going to adjust my circle and see if I can make it any smaller while still keeping the district totally enclosed in the circle. And I'm kind of keeping an eye on that area calculation to make sure that I'm actually making the circle smaller and not just moving it around. And the trick kind of is to make sure that the widest part of the district is going across the diameter of the circle. And I think that's about as good as I'm going to get it. Now we want to divide the area of the district by the area of the circle. So again, using number and then calculate, I just click on the area of the district divided by the area of the circle. This time my compactness ratio is 0.39, so the rock method tells me that this district is less gerrymandered than the convex hull method did. Now I'm going to do the calculations for the Polsby-Popper method, and I again added a blank page to my sketch and then copy and pasted in my district map, the polygon that overlaid my district, and the area of the district. The Polsby-Popper method tells me to construct a circle whose circumference is the same as the perimeter of the district. So the first thing I'm going to do is measure the perimeter of this polygon. Now that I know the perimeter of the district, I want to figure out what size circle or what radius circle do I need to have that be its circumference. Circumference, of course, is 2 pi r, and I need that to equal 17.11. So I want a circle whose radius is 17.11 divided by 2 pi. I can have Sketchpad calculate that number for me. And to get pi, just type the letter P and the pi popped up. And now I need to construct a circle that has this radius, 2.72. The easiest way to do that is to first construct a segment that has that length. And the easiest way to do that is to take a point and then translate the point using the transform menu, 2.72 centimeters. And you can transform points either using polar coordinates or rectangular coordinates in Sketchpad. And if you're going to use polar coordinates, just translate it 0 degrees so that it moves directly over. Of course, if you're using rectangular coordinates, you would just want to make one of your dimensions 0. Now that we have those 2 points, we can just connect them with a segment. Then with the segment and one of its endpoints selected, we can say construct circle by center radius. Now that we have this circle, we want to divide the area of the circle by the area of the district. So first let me measure the area of the circle, and then using number, calculate, divide the area of the district by the area of the circle. This time I get a compactness ratio of 0.35, so somewhere between the rock method and the convex hull method. Last but not least, I'm going to calculate the modified Schwarzschild compactness ratio. I've again added a blank page to my sketch and copy and pasted the relevant information in from the prior pages. The modified Schwarzschild method wants us to construct a circle whose area is the same as the area of the district. So we need pi r squared to equal 8.2. So we need r to be the square root of 8.2 divided by pi. We're going to again have Sketchpad calculate that number for us. And to get square root, I just type the letters S and Q. And I need a circle whose radius is 1.62. Again, we're going to construct a point and then translate that point, connect those with a segment, then with the segment and one endpoint selected, construct the circle. Now we're going to want to compare the circumference of this circle to the perimeter of the district. So I'm going to select the circle and measure its circumference, and the district and measure its perimeter, and then calculate the ratio of those two. And this time the circumference goes on the top and the perimeter goes on the bottom. And I get a compactness ratio of 0.59. So again, even a different measure than I had with the other 3 methods.